Welcome to session 6 of Unit 4, Mode and Media from Probability and Cumulative Distribution. So by the end of the session, we should be able to obtain the mode from a probability mass function, find the mode from a probability density function, and determine the median from a discrete cumulative distribution function. Obtaining the mode from probability distribution function. It goes straight to, for example. So if you have a PML, that's probability mass function of a discrete random variable x, given by x assuming zeros from 0, 2, 6, and 8, and 8 corresponding probabilities, we are asked what is the mode of the distribution. So in a simple language, solution: the value of the random variable x which has the highest probability, that is 4 on 9. Remember, 4 on 9 is not the mode. The random variable x which has the highest probability, that is the mode. You get it? Yes. So in a simple sentence, the mode could be defined as, the mode of a discrete random variable may be defined as the value of the random variable which has the highest probability of occurrence. So we started with the example before getting the definition. Now you got it now. So the mode of a discrete random variable is defined as the value of the random variable which has the highest probability of occurrence. So in this case, our mode here is 6, because 6 from the random variable has the highest probability, that's 9/4. Hence the mode is 6. For the case of a continuous probability distribution, the mode is obtained by we equating the derivative of the probability density function to 0. And hence we solve for that random variable. That will give us the mode. Yes, did you get it right? I think for the continuous distribution function, the mode is obtained by we equating the derivative of the probability density function. The function given us, we find the derivative, or we differentiate the function, equate the function to 0, and solve for the random variable there. And that will give us the mode of the distribution. So look at example 2. Example 2. The PDF of a random variable x is given by, that is 6x multiplying the expression 1 minus x with the interval 0 to 1 or 0 otherwise. We have to find the mode. Now remember that the solution to this is that the mode should be the derivative of the function given, and equating the derivative to 0 and solving for the random variable x. So differentiating the function given, the function is 6x multiplying 1 minus x. So we can multiply before differentiating. Multiply 6 with 1, we have, multiply 6 with 1, we might have what? 6x. And then multiplying 6x with minus x will give you minus 6x squared. So when I differentiate 6x, I'll get 6. Differentiate 6 minus 6x squared, I'll get minus 12x. Now this, so 6 being common to both sides, can divide through by 6. I will have 1 minus 2x here. Now that's a derivative. So we equating this to equal to 1. We have 1 minus 2x equal to 1. And we having x to be equal to 1/2. Hence the mode of the distribution is 1/2. Very simple, right? Good. Determine the median from cumulative distribution function. You talk about mode. Let's look at the median. The median from a cumulative distribution function. A random variable x has a density function f of x. Now, if you have a random variable and you want to find the median, now it's telling us that the median could be found by if probability of x is less than a small x, then f of x should be equal to 1. Sorry, it should be equal to 1 over 2. Otherwise, we'll have if f probability of x, assuming small x is greater than probability of x is greater than or equal to small x, then we have 1 minus f of x equal to 1 over 2. That is how we find the median. We equate it to half. So let's take example 2. A random variable x has a density function, and the function is given at 3x squared with the interval 0 to 1, 0 or otherwise. You should find the median of the distribution x. So to find the median, now we realize that for x is less than or equal to small x, we integrate from 0 to x, replacing our x in the function with t, and we integrate along the path of t. And integrating this will give us t cubed, and we're giving us a limit 0 to x. We'll have this will be equal to x cubed. And we are told that we equate the integral of whatever we've gotten to equal to half. So our integration is given as x cubed. We're equating x cubed to equal to 1 over 2. Finding x will give us the cubic root of half. So here's the median is a cubic root of